Okay guys, hi, I'm Mr. Lupos here making a video in response to a question I had from a classmate of yours for U2A6, more about horizontal asymptotes than anything else and vertical asymptotes also. But let's do a quick review for U2A6. Let's not do that. Let's do this, if I can get there. Okay, so what I've decided to do for this part of the course, I'm using Desmos, and I'm also going to use this little applet from your course. So I'm going to look at this function here, f at x is equal to 7 over x plus 3, and I'm going to cheat, and I'm going to find out what that looks like if I graph it. So there we go, 7x plus 3 looks something like that. Okay, and then we're going to try to make sense of, looking at this, trying to make sense of how we could sketch this by using all the information we know. So if I go over to, let me go over to Smart here for a second. So I had, what did I have, 7 over x plus 3. So there's my function, and I want to know how to sketch this. First thing you want to look at is your x and y intercepts. So when you set x equal to 0. So when x is 0, I have not moved side to side at all on the graph. So that's my y-intercept. And if I set x equal to 0 here, I'll write it all over the place, then I'll erase. That is y is equal to 7, 0 plus 3, which is then going to be 7/3. So my intercept there is going to be at 7/3. 7/3 is just over 2, so 2 and a bit. So there's my intercept. And let's see if that makes sense. Go to Desmos. Is that what I had there? Let's go here. 7/3. 7/3, 2 and a third. That's right there, 0. It's 2.33. So there's an important point. Another important point will be my y-intercept. And if you went back there, it looked like, sorry, that's my y-intercept. My x-intercept, if you look back on the sketch, it doesn't look like we have a y-intercept, and let's see if we can prove why that's true. A y-intercept takes place when x is, sorry, did I say y-intercept? An x-intercept takes place when y is equal to 0. So I'm going to set this function equal to 0, and then I'm going to say, how is that true? When does that, what value of x makes this true? What I'm going to do is I'm going to multiply both sides by x plus 3 or swap these out, and you're going to realize this doesn't work. Because then if I bring this down here and bring this over here, then I end up with 7 divided by 0, and that's undefined. Or even if I said let's multiply both sides by x plus 3, well, then I would have 0 equals 7. If I have 0 times x plus 3 equals 7, which would say 0 equals 7, and that's not good. Okay, so we have no intercept on the x-axis. Okay, and then that gets us going. Okay, and then the asymptotes. The vertical asymptotes are a lot easier. So I'm teaching the grade 11 in class right now over at Beal, and what we look at are the restrictions, and you look at the denominator and you say from here, x cannot be equal to -3, or you just take a factor from the bottom, in this case x plus 3, you set it equal to 0, and you solve this out, okay, and then x equals -3. If that was true, if x was -3, then I'd have y is equal to 7, or y is equal to 7, -3 plus 3, which says that's 7 over 0, which is no good, undefined. Okay, so I am going to say that x cannot be -3, so 1, 2, 3, dash line coming down like that for this asymptote. And let's go back after I clean this up. Let me get my eraser out here. Check this out. Clean it up, magic eraser. So I have, put this in red so you can see a little better. This guy here, this thing here. And then let's go back and check Desmos. Am I right? Is it 3? Yeah, it is. -3. 1, 2, 3. It's harder to see here. But if you notice, as I approach -3, I get nothing out of this. So now what I want to do is just go back and see if that makes sense. If you can make sense of this little applet here that comes with the course. So that goes over the asymptotes here, -3, good. And then we want to look at, notice how the values of f and x keep getting smaller and smaller to the left of x minus 3 and keep getting higher and higher to the right of x -3. So what that means is what's going to happen when I approach my asymptotes from either side. So if I look over here, I want to find out, does this go, so I'm going to pass through here. Am I going like this down here, or am I going up here? So going back to that, it says here, as I get closer and closer to -3 from the right side, so as I come in from this side here, so let me go back to this real quick. That's this stuff here as I go from -2 towards -3. So as I'm coming in towards -3 from the right side, these numbers get bigger and bigger and bigger. And how do you get these numbers? Well, you just plug them into this equation here. 7 over -2 plus 3 is 7 over 1, which is 7. And as you make this big number bigger, or sorry, closer to -3, so smaller, I guess, -2.5, -2.99, this gets bigger and bigger. F at x gets bigger and bigger. And because of that, as you approach from that side, let me go back to this Desmos real quick, it gets bigger and bigger and takes off. And when we sketch it ourselves over here, we're going to have something like this happen. So let's do our graph in green. We're going to go through here and we're going to take off like this. Okay. Now, I don't want to draw too much more because I don't know where the horizontal asymptote is at this point. So I don't know if I'm leveling off here or if I'm leveling off here, and I don't know what's going on this side either. But I do know, I do know that as I approach from this side, so back to this guy here, as I approach from -4, this number gets smaller and smaller and smaller. So -4 is gives me an f at x at -7. X of -3.5 gets me -14 as my y value. And as this gets closer and closer from the left side now, as I approach f at x, it's going to get smaller and smaller and smaller, which is great. But I don't know my horizontal asymptotes, so I don't want to sketch too much yet. Now, the horizontal asymptotes really are a lot easier than what we have going on, at least for these simple ones. They're a lot easier than all the stuff that's on the applet. Really, what all you're going to do is look at the ratio between the whatever's on top and whatever's on bottom as far as the variables go, the leading coefficient of the highest variable. And if you look here, I have no variable on top. So really I have 0x plus 7. And on the bottom I have 1x plus 7. And what you're going to look at is what is the ratio of these two numbers here. And the ratio of 0 to 1 is just 0, so my horizontal asymptote is, in fact, 0. So whenever you have a bigger degree on the bottom compared to the bottom, sorry, a bigger degree variable on the bottom compared to the top, like in this case I have an x here, I don't have anything, my horizontal asymptote will be 0. And how does that make sense? That makes sense because as x approaches, so we look at and if you look at the note, it says what happens as x approaches infinity and x approaches -infinity. So x approaching infinity means I'm going way over here. And as this gets bigger and bigger and bigger and bigger, what happens is I have 7 over a giant number because it's x plus 3. So that's 7 over a huge number. And as this gets to be a huge number, so 7 over like a million, or as many zeros as you want, that it gets pretty darn close to 0. So because 7 over a small number like that is very small. So that means that this is the asymptote here. And as I go this way, I get closer and closer. Excuse me for using the wrong color. And then on the other side, same with this. If I get to negative, if I put 7 over -1 million or a trillion or whatever you want here, that is also going to be 0. Okay, because I have a much larger number on the bottom. So if I have a small bit on top and a huge thing on the bottom, this whole thing gets to be very small and it approaches 0. Now, that's not always the case. So that's not what happens in every case. And let me just finish this up here. We looked at earlier, we said that as this approached the asymptote, as this approached -3 from the right, so -4 to -3.5, as we moved on, this got to be negative, went towards -infinity, so it got very big this way. So that's how I draw this on this side, okay? But this is not always the case, and what happens is if you don't have the same value on top and on bottom, as far as the degree of the variable, that it is the case. But if you do have the same value, then you're going to have different asymptotes. So if I had something like this, 3x plus 1 over 6x plus 2, my asymptote would not be 0. And for the example that I'm going to use for this, I'm just going to erase everything here. I'm going to use an example that is in your textbook, not your textbook, sorry, your coursework, your content work, in U2A6, and the example I'm going to use here is going to be, what is it? I can't remember, is going to be this guy right here, 2x over x minus 2. So 2x over x minus 2. And then here are the answers. So what I want to do is explain what I'm talking about, and then you can go back and check what's written in the content and compare it to what we're going over and also what you see on Desmos here. Use Desmos all the time, guys. Get it out either on your phone or whatever you use, and have it beside you as you go through these questions. So I have f at x is equal to 2x minus 2. So let's go ahead and throw that in here. So 2x minus 2. Oh, so let's delete everything here. I got 2x divided by x minus 2. And it looks something like this. Okay, so I have some asymptotes here and here, and you notice your horizontal asymptote isn't there. So we can go through the whole process and figure out what your y-intercept is and your x-intercept, set this equal to 0, set y equal to 0, and move on. But just running a little long on time here, so let's just look at the horizontal asymptote. And the horizontal asymptote is going to be 2. Okay, so the horizontal asymptote is 2 here. And if I scrolled out and I got really far away, you notice that these two lines, this side of the line, this side of the line never hit the value of 2. And how does that come to be? It's very simple. I think the textbook gets a little bit too detailed on this. All you do is look at the ratio of what's in front of the x and what's in front of this x. And just like I said before, if you don't have an x on top, you have 0 x's on top. So your asymptote is going to be 0. But here where I have 2 and I have 1, your asymptote is just going to be 2 over 1, 2. And if I had negative up here, it would be negative 2. So check over here. And if I go, one thing that I can do is this. So you can see this a little better. No, not here. Where's this? Projector mode. So you can see it just a little bit better. I have this, okay? And if I change this to 7, it's going to be negative 7. And if I change this to, let's go with something that will reduce 6 and 3. 6 over 3 is 2. And it's hard to see the scale right now, but that is going to be 2. Okay, so 1, 2. And that's it. Okay, that's all you do. And if this was squared, okay, and the bottom was squared, same thing. Okay, 2. It's always the ratio here of the leading coefficient of what's on top and what's on the bottom. But let's just stick to this stuff for now. And I messed this up. So whatever you got there, that's your horizontal asymptote, and then you treat to figure out how to sketch further. Look at what happens as you approach both negative and positive infinity. So for example, let's go back to one we had. What was that? 2x divided by x minus 2. Enter. So as x gets huge, okay, as x gets enormous. So just to think about this, as x approaches positive infinity, way over here, way over here, way over here, it's going to approach 2 because what you have here is 2 times a huge number over essentially the huge number itself, right? Because if you have a million up here, you have 2 million over a million subtract 2, which is close to a million, and that is essentially 2. And as you get bigger and bigger and bigger, it gets closer and closer to 2. And on the other side, same thing, you're going to have negative infinity, so 2 negative numbers here, and that's how you get your asymptote. Okay, and that's it. Key points, vertical asymptote also on this one. Let's change this up. I hate when we do this, but for some reason we have 2 and 2. Let's change this to 5. We still have the same horizontal asymptote, right? 2 over 1 is 2. But the vertical asymptote is based on what happens if how would I make this 0 here? Okay, so x minus 5 cannot equal 0. X does not equal 5. So change the sign here, and then that's how you get your vertical asymptote. Okay, good luck.